초콜릿은 달콤해 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 오렌지는 상큼해 상큼해 상큼해.
So before I start to discuss my topic about graph of circular functions, by the way, I am Beverlyn Pakunakitay, a second year student from Nurses Shatten campus. So, what is the graph of circular functions? So the graph of this equation x2 plus y2 equals 1 is a circle in the rectangular coordinate system. So this graph is called the unit circle and has its center at the origin and has a radius of 1 unit. So trigonometric functions are defined so that their domains are sets of angles and their ranges are sets of real numbers. Circular functions are defined such that their domains are sets of numbers that correspond to the measures in radian units of the angles of analogous trigonometric functions. So the ranges of these circular functions, like their analogous trigonometric functions, are sets of real numbers. So these functions are called circular functions because radian measures of angles are determined by the lengths of arcs of circles. In particular, trigonometric functions defined using the unit circle lead directly to the circular functions. So begin with the unit circle x2 plus y2 equals 1 shown in figure. So point A is the coordinate of 1 and 0 is located at the intersection of unit circle and the x-axis. So let Q be a real number. Start at point A and measure Q units along the unit circle in a counterclockwise direction. So if Q is greater than 0 and in a clockwise direction, if Q is less than ending up at point P, x and y determine the and cosine of Q as the coordinate of point P, the other circular functions, the tangent, cotangent, secant, and the cosecant, can be defined in terms of the sine and cosine. So in figure number 2, range of values of trig functions. So example number 1, what values x and the domain of the sine function between negative 2 pi and 2 pi have a range value of 1. So in figure 3, so drawing for, so example number 1, the range value of sine x is 1. So when point P has coordinates of 0 and 1, so this occurs when x equals pi over 2 and x is equal to negative 3 pi over 2. So example number 2. So what values x in the domain of the cosine functions between negative 2 pi and 2 pi have a range value of negative 1? The range value of cosine x is negative 1. So when point P, cosine x and sine x has coordinates of negative 1 and 0, so this occurs when x equals pi and x is equal negative pi. So let's move on to example number 3. So the point P is on the unit circle. The length of the arc formed from point A is 1 and 10. So the two units, what are the values of the 6 circular functions of Q? So the values of the sine and cosine follow from the definitions and are the coordinates of point P. So the other 4 functions are derived using the sine and cosine. So the sine of each of the 6 circular functions, so let's look at in table 1. So is dependent upon the length of the arc Q. So note that the 4 intervals for Q corresponds directly to the 4 quadrants for trigonometric functions. So for now, let's proceed about the circular function. So we have 6 circular functions. So unahin natin yung nakikita natin sa unit circle, which is the cosine theta, sine theta. So we also know that cosine theta is equivalent to x and sine theta is equivalent to y. So this is the first 2 circular functions that we have. So for the third one, so we all know that the tangent theta is equal to sine theta to cosine theta. So from this way, we can say the tangent theta is equivalent to y over x because sine is equal to y and cosine is equal to x. Now, let's have the second theta. So second theta is equal to 1 over cosine. So as you notice, this is just the reciprocal of cosine. So if cosine is x, second theta is equal to 1 over x. So 1 over x is the reciprocal of x. So let's have the cosecant theta. So 1 over sine theta is the reciprocal of sine theta. So sine theta is equivalent to 1 over y. So 1 over y is the reciprocal of y. Now, let's have the last one, the tangent theta. This is equivalent to cosine theta over sine theta. So it is equivalent to tangent theta. Therefore, tangent theta is also equivalent to x over y and reciprocal to y over x. Now, this is the 6 circular fractions. Now, let's have our example number 1. So, find the 6 circular fractions of pi over 3. So, I will be giving you 2 options in getting the 6 circular fractions. So, the first one is by using the unit circle, and the second one is by using the special right triangle. Now, let's have a unit circle. So, this is just a partial of unit circle. So, this is the quadrant 1 because in the quadrant, we can see our given, which is pi over 3. So, pi over 3 is in 60 degrees. Ordinate with 1 and 2. 1 over 2, that is the abscissa, and square root of 3 over 2. So what is the y-axis which is the y-axis in the coordinate? So from these coordinates, we can obtain the 6 circular functions. So this is the first option. For the second option, if you do not have your unit circle with you, or you don't have any idea about circle, you can use this special right triangle. So the first thing you need to do is to convert the radian measure. Kasi nasa radian measure siya. So we're going to convert it in degree measure. So in converting radian to degrees, we simply multiply 180 over pi. So this is pi over 3x. So this natin siya, so multiply natin siya sa 180 over pi kasi which is 60 degrees. So now since the degree measure of our pi is pi over 3 is 60 degrees, we can use the special right triangle. So 30 by 60 and 90. So you can also use this triangle in obtaining the 6 circular functions. So again, if you don't have your unit circle with you, you can use the special right triangle. So if you have cosine 60, using the SOHCAHTOA, cosine is equal to adjacent over hypotenuse. So what is the adjacent side of our 60? That is 1 and hypotenuse is 2. So that's why we have 1/2 as our cosine 60. So now let's have our sine 60. So sine 60 is equal to pi 3 over 2, so that is the coordinate of our ordered pair here. So sine in the SOHCAHTOA is the equal opposite over hypotenuse. So the opposite side of 60 is pi over 2 over hypotenuse. That's why we have square root of 3 over 2. So since we have cosine and sine, we can have our tangent. So tangent 60 is equal to sine over cosine. So sine is square root of 3 over 2 all over 1/2. And so 1/2 is our, so since we have complex functions in reciprocal to the denominator and multiply it to the numerator. So in doing, we will have square root of 3 over 2 multiplied by 2 over 1. So 2 over 1 is the reciprocal of 1/2, then we can cancel 2. So then our tangent 60 is equal to square root of 3.